Okay, so now we'll actually get into a bit more here of actually designing for additive manufacturing. So the first thing we're going to talk about is designing support-free parts. And this first slide is dedicated to SLA. Now SLA, remember, it has a vat of liquid, and as it cures, it drops down into the vat. That does enable us to do some kind of cool things. And in this case, we're going to talk about internal passageways. So with SLA, anytime you can eliminate the need for the SLA machine to build support, you'll reduce the cost and lead time for your parts due to the reduction in manual labor. Again, remember, sandpaper equals time equals cost. Less sandpaper is a good thing for you, the customer. If you're printing parts with complex internal structures, you'll also want to avoid support that cannot be removed from inside of them. So specifically on this slide, I'm talking about the archway right here and these pockets in the side. As you can see, those are all inside the block. The block isn't split into two or anything like that. So any support that's inside of that core structure, we will not be able to remove. But because the build material is liquid, we can drain it out. So that can be all drained, but we can't get the solid structure out. But there are ways around that. So by thinking ahead with your design and working with the 3DP machine operator, you can eliminate most of the support specifically on this SLA part. Using an arch or any top surface that is steeper than 45 degrees, you will not need to use support to print it. So you can see we have a traditional arch right there in the center of the part, and then we have these vacuum chambers are actually at like a 60-degree angle. None of that will require support to print. That is all self-supporting structures. This hole through the center of the block, again, it's an arch. The top of it is an arch. You do not have to print support inside of there. It's important to get buy-off from the machine operator that you're working with. If you're subbing out stuff like this, they may have certain things they want you to tweak or adjust, but those are pretty good rules of thumb that you can depend on to be true pretty much no matter who you're working with. I like to use the SolidWorks draft analysis tool. So this guy right here, and that's these bottom images that you can see. I actually have draft analysis turned on, and then I did a section cut through the part. And anything that, and draft analysis doesn't work perfect. So in this case, there's a lot of yellow, but just kind of ignore that. I'm looking at those green faces specifically. Those are the faces that are going to require support. I have my draft analysis tool set up so that anything under 45 degrees, it's going to throw a flag. And it's super handy to just quickly use this tool, look through your part, and check your work. And especially if you have complex parts where there's a lot going on, this can save you from missing it in one little area and scrapping a part. The only area on this part that's actually going to require any sanding are these downward faces. So you can see these are screenshots out of our 3D printing prep software. So that blue is actually support structure that'll get ripped off after it's printed. And anywhere where that blue structure is at, there's going to be stubble left behind, and we have to sand that off to get a nice smooth face. Well, this is a flat face. I can take a piece of sandpaper, I can take this face, and within about a minute, I can have it completely smooth. That's a very, very minimal cost to the customer versus having a bunch of interrupted cuts or, crazy geometry that we have to work around on the bottom. I mean, if you got to have it, you got to have it. But if you can make a nice, smooth, flat surface, you're going to save yourself cost on the post-processing. So that is designing support-free parts for SLA. Let's move on. So next up, we're going to talk about designing support-free parts for the FDM process. So a bit different from SLA in that you can do more thermoplastics and things like that. Also, you can do wash-away support. So with SLA, you have to break your supports off. With FDM, you can actually use water-dissoluble supports that will basically wash off your part after printing. You also sometimes have to use breakaway supports for certain things like polypropylene and things like that. But the trick to designing a mostly support-free FDM part If possible, design a large flat surface to lay your part onto the bed of the printer. This accomplishes a few different things. This large flat face can be printed directly onto the bed of the printer. This eliminates the need for any support on this face. So, again, different from an SLA machine, you have to build support under an SLA part. With FDM, if you have a flat face, you can put that directly on the bed of your printer. The downward face will be very flat because it's being built on basically a piece of glass. And also, you can media blast it after printing, and it will almost give it an injection molded look, which is desirable for certain people. Also, by putting a large flat face onto the print bed, it really helps your part stay stuck onto the bed. So MJF parts, because it's a hot process, a thermal process, they do tend to want to warp, or sometimes the edges want to pick up, especially with a tall part where the middle of your part can start to get pretty cool, and you're printing hot at the bottom, and you've got a heated build platform. Those tend to want to warp a lot of times. Having a big flat face stuck onto your build platform can really help eliminate that warping during the printing process. A bonus tip for parts that are being printed on an FDM machine, to allow for really nice round holes. Actually point your holes up in the Z direction so that your print head is building your hole this direction and not trying to build your hole, with it facing, across the bed in the X or the Y direction. Those holes tend to come out more kind of egg-shaped, whereas in the Z direction, you get a really nice, true round hole. So this blue part that you can see on screen here, this is actually a face that was printed directly onto a glass bed of a FDM printer, so it's got a really nice finish on it. And these holes that go through the part where this roller is trapped, because those are printed up in the Z, we get really nice round geometry for that roller to slide on inside of that part. Another nice feature of laying it down, we have these ramps on either side of that roller. This is actually an applicator for applying tape to an extrusion. By having those profiles being laid down in the Z direction, we don't have like a stair step effect. FDM is a layer-based process, so you will have, stair steps. You can see the layer lines in the sidewall of that part. You can even see the layer lines in that ramp right there. But they're going, in this direction, so it's a nice smooth transition. You don't have a bunch of stair steps in there that you have to sand out. So again, these are all things to think about when orienting an FDM part, especially trying to eliminate any support from that part. Okay, well, that is my presentation. I appreciate your time and sticking with me here to the end. We covered a lot of ground today. Definitely hit me up and I'd be happy to share this slide deck with you. Again, Paul DeWise, and you can see on the screen here is my email address. So, shoot me an email, or I'm extremely active on LinkedIn as well. So please reach out and connect with me on LinkedIn and, slide into my DMs. I'd be happy to send you the slide deck that way as well. Also, I'm always happy to answer questions or give feedback on design. So, if you're working on something and it's going to be 3D printed and you're looking for someone to be a second set of eyes, feel free to reach out to me. I do a lot of that. And also, one last shameless plug, check out our website, forerunner3d.com. It's got a ton of great information. We do a lot of testing and a lot of R&D, and we publish everything to our website. So there's great design guides for all the technologies we talked about today, with a lot of content that you're just not going to find anywhere else. So thank you so much for your time and attention, and look forward to hopefully hearing from you.